Into a little bit more definitions now for the part 3 of your 1.3 lesson. And we're going to start classifying numbers. For a lot of people, this is really hard because there are a lot of terms when it comes to this. So you can classify numbers using sets. A set is a well-defined collection of objects. Just like if I would say, hey, my classroom. My classroom can be a set, all right? I can say, hey, I have a set. It is my classroom. It is your guys' class, all right? So whatever class you're in. It could be Algebra 1, it could be Algebra 1A. Whatever class you're in, you can be a set. If I say, my set is my second block, that is a well-defined collection of objects. Okay? Each object is called an element of the set. So, each person in that class, in my Block 2 class, is called an element. They are an element of that set. Alright? They are called an element of the set because they are part of the set. Make sense? They are an object in the set. A subset is a set that consists of elements from the given set. Okay, notice it says from the given set. So if I said that my set was Block 2, okay, a subset of that set would be the first row of tables, right? Anybody in that first row of tables would be classified as a subset. Why? Because they are a part of Block 2. They are part of that class, right? I could even say a subset would be the second row of tables or the third row of tables or just me. Am I a subset of Block 2? Yeah. I'm part of the class, right? I'm the teacher, but I'm part of the class. So there's tons of subsets within a set. I could say even a subset is everybody in the class except for the first person in row 1. All right, would that still be a subset? Yes, because again, a subset is anything within a given set. So I'm still talking about the people in Block 2. So therefore, it would be a subset. Okay. Now, the fun part. Oh, and the subset and all that stuff will come back into play later on. I believe it's chapter 4. Maybe chapter 3. I think it's chapter 3. So, rational numbers is a number that you can, or is any number, any number that you can write in the form of a over b, where a and b are integers, and b cannot be 0. Again, why can't b be 0? Because if sorry guys. If I were to put a over 0, or even let's say 6 over 0, is that possible? No, it's not. And you'll understand later on that we call this undefined when we talk about slope. But this is not possible. That's why they're saying b cannot be 0. And integers you're going to see here in just a little bit. Natural numbers. They're counting numbers. Okay? Natural numbers are anything I can hold in my hand. All right? I can hold 1 paper clip. Okay? I can hold 2 paper clips, 3 paper clips, 4 paper clips, and so forth. All right? That is a natural number. I can touch those. All right? I cannot touch nothing. Yes, some of you guys are going to say, well, there's air particles and all that great stuff. All right, yes, okay, great. But as far as actually touching nothing, That's not possible, okay? So a natural number is anything really that I can touch. I can physically hold in my hand. All right? Whole numbers. Notice that whole numbers include counting numbers and 0. Okay, so is 0 a natural number? No, it's not. Again, because 0 I can't hold. But is 1 a natural number as well as a whole number? Yeah, it is. Because 1 is a counting number and whole numbers are counting numbers and 0. So therefore, a natural number is always going to be a whole number. Can you give me that one case where whole numbers are not always going to be natural numbers? Good. If you said 0, that's awesome. And when we talk about this, you guys have got to be listening to the wording. You have got to read your problems carefully, because when it comes to this, one word will throw it off. Okay, so you've got to be really understanding what is being asked at you, and I know that that is hard. Okay, integers. Integers is a whole number and their opposites. Well, notice that whole numbers are counting numbers and 0. Integers are whole numbers and their opposites. So again, with a case of 1, 1 is a natural number. 1 is a whole number. 1 is also an integer. Why? Because integers say whole numbers and their opposites. And isn't 1 a whole number? Good, so therefore it's also an integer. Okay, but it says they're opposites. So what's the opposite of 1? -1, right? Let's put this over here. -1. So now here's my question. Is -1 a whole number? Nope. Is -1 a natural number? Nope. I cannot fill a negative something. It's not possible. So do you see how I can climb up or climb down in this case? I can go from natural to whole numbers to integers. Yeah. Okay. And rational numbers? Rational numbers are all of these. Okay? So literally every natural number is a rational number, because I can write 1 as a fraction. How can I write 1 as a fraction? 1 over 1. I can write 0 as a fraction. I can say it's 0 over 6, and isn't that really 0? Yeah. I can write -1 as a fraction. How can I write -1 as a fraction? -1 over 1. So all these are rational numbers. Okay? A good thing to remember too about rational numbers is that they terminate or repeat. What does the word terminate mean? If I'm terminating you, I am good. You ended. If somebody gets terminated from a job, they are fired. They are no longer working there. Okay? You end. Your career and that, your employment at that place is ended. Okay, irrational numbers cannot be represented as the quotient of two integers. What that really means is they are decimal that never repeats, nor terminates. So an irrational number is a decimal that never repeats nor terminates. Can you give me one number that we talk about what irrational number that we talk about quite a bit in math, especially in geometry, that never repeats nor terminates. I will give you a clue. The number is often celebrated on Albert Einstein's birthday. Good, it's pi. Pi is pretty much one of the number one irrational numbers that people associate with. Anytime I talk about irrational numbers too, I talk about my grandma. My grandma can be an irrational person because she keeps talking and talking and talking and talking, but she never repeats herself. She never repeats herself. You can sit with her for 6 hours and just talking to her, and she's never going to repeat herself. She's going to just keep talking about random things. Okay, so those would be the classifying of numbers. And and I think we already talked about this, yeah. So we already talked about irrational numbers cannot be represented as a quotient of two integers. Irrational numbers, when written as a decimal, never repeat, no terminate. This is a biggie. We had that on the other side. But this is like, if you can remember this, then again, when it comes to your homework assignment, it's going to be a little bit easier. All right, so that concludes the vocabulary part of this part of classifying numbers.